Hi, let me explain about permutation and combination. Okay, so beginning of the chapters we will see the fundamental of counting. Yeah, before we can understand on permutation or even combination, so first thing we must know what's the counting principle. So counting principle, so when we say counting means count, of course, 1 2 3. Okay, but this counting principle that we are saying is a way, okay, to determine the possibility outcome. Okay, when there are certain event, okay, we want to know how many possible result that we can get. Okay, that is on, we will use the counting principle to get that. Okay, so let us see on one simple example. Okay, first thing is if I have an event, okay, or a situation, okay, where the student roll a die and then he also flip a coin, that means together the student roll a die, after that he flip a coin. So what is the outcome that it can be? So if we think logically, okay, it may have the number 1 with the head, okay, 1 at the die, head at the coin, okay, or 2 with at the on the die, okay, the number 2 shown up, okay, and then the coin still have head, or you have number 3 on the die and then head coin, or and so on, or you have tail, now the coin showing tail, and then the die may be the number 1 to 6. Okay, so that means here you will see there are 1 2 3 4 5 6 until there are 12. Okay, there are 12 possible outcome. Okay, now this is simple example when the student roll a die and flip a coin. Okay, so if we do like listing it out, okay, we list it out like this, 1H we write it down, then we can count there's 12 outcome. Okay, but how to make your life easier? Okay, so this is what we call the counting principle here. Okay, so the counting principles here says that if I have a die has 6 outcome, right? So this number 6 here, okay, this number 6 shows that from the first event. Okay, then the 2 here in the second event. So if this event happen together, so we multiply it, we will have 12. Okay, this is 12 outcome. So in order to say using the same method, if I have 2 die, okay, 2 dice, okay, then a coin, that means my possible outcome I will have 6 times 6 times 2. Okay, so because of 2 die you have 2 6. If you have 2 coin, 1 die, then 6 times 2 times 2. Okay, 24 outcome. Okay, so that is the principle of counting. I hope you understand the logic behind it. We can either list it out, okay, we list out everything here, or we use the principle. The principle says we just multiply the outcome for each event. Okay, now let us see. So another example here. So for the college interview, Robert has to choose what to wear. So you have either wear the slack is the pants, or shirts. There are 3 types of shirts for him to choose, or 4 types of slack, 2 types of shoes, and 5 types of ties. Okay, so how many possible outfit? Okay, so let's say K1, K2, K3, K4. This one is for the shirt, the slack. I use a symbol to represent. Then R1, R2, R3 is the shirt, S1, S2 is the shoes, and T1 until T5 is the tie. So if he has to wear one of these from each item, from each category, he has to wear one of it. So if we do combination, we do matching. So in this Robert, okay, he can wear K1, okay, slack number 1, then with the shirt number 1, with the shoes number 1, and also the tie number 1. Or maybe he choose to wear the slack number 2 and the rest is number 1. So if we keep on counting, okay, we can keep on counting and count and list down all the possibility. Okay, or we just do like this. So 4 outcome for the slack, 3 for the shoes, and 5 for the tie. We just multiply, and actually we can know that there is 120 different arrangement, okay, different type of outcome, okay, that he might have. he has to choose. Okay, he have to choose. So that means we no need to list out all the 120 and then count it. Okay, so we can just do the using the counting principle. Okay, hope you understand this. Okay, so from the counting principle we will see permutation. Okay, so permutation, so in the definition it means it's a mathematical technique. That means we don't use the counting is more basic. Okay, so from the counting principle we go to a technique, okay, which involve formula, of course. Later we see what is the formula. So this mathematical technique is more systematic, okay, where you can explain and you can use it widely, okay, more example or more different situation. Okay, and then we can determine the number of possible arrangements. See arrangement here, and then when the order of the arrangement is matter. So order of arrangement is matter. What is meant by orders are matter? Okay, orders are matter. It means that to find the number, okay, to do this, okay, we can use two way lah. Okay, either use counting, and then you can use the factorial notation. Okay, the factorial notation. So what is meant by orders matter? So first thing here, let us see. So the number of ways to arrange. Example 1. Okay, orders are matter. For permutation, you must know that the order is matter. So I need to find the number of possible ways that I can arrange the letter ABC. So first thing you do is there are 3 letters, right? That means there are 3 space for arrangement. So how to arrange ABC? Okay, so the first way is, okay, how to arrange ABC, you see. So the first blank you can choose from 3. That means there are 3 ways. Okay, either it's A, B or C. That's why we put a 3 here. Okay, for the second blank, the second space here, okay, if A is taken, I left B and C. If B is taken for the first space, I will left A and C for the second one. That means the second space always left with 2. One is taken by the first. Okay, one letter is taken by the first one. Okay, there are left only 2 possible. So the third place is only 1 possibility. Okay, that means the total outcome that I can get is 3 times 2 times 1. Okay, can see that? So there are 6 possibility. Okay, equivalent to 3 factorial, 3 ways of 3 letter or 3 space. Okay, 3 factorial. So you also get 6. The meaning of factorial is you will times the number after number 3. That means going descending order, 3, 2, 1. Okay, if 5 factorial, you will times with 5, 4, 3, 2, 1. Okay, so check our answer whether it's correct or not. Okay, so that means if the first space, okay, is taken by A, the second is B, and then C. This is one of the example, one of the arrangement. Or you have ACB, or you have BCA, and then you have BCA, CAB, and BCBA. Okay, so this 1, 2, 3, 4, 5, 6, all of them are using the same letter. Okay, because of the orders are matter, ABC and ACB all are different method or different arrangement. So they are all together 6. Okay, so 6. So let us see another example. Let's say I'm not going to arrange all the letter. So I have ABC. I arrange all ABC. There is 3 letter. I have 3 letter. I arrange all the 3 letter. Now I have 5 letter here, A, B, C, D, E, but I only arrange 2 letter. So what is the possible way or the possible outcome? So first thing, how many choice for the first blank? Okay, the first space here. So I have A, B, C, D, E. So I have 5 lah. 5 letter. Okay. Then the second blank. Yes, I have 4 only. Okay, because 1 is taken, I left 4. So by listing out all the possible arrangement of 2 letter, okay, I can get AB, or I got AC, or I got AD, or I got AE, and so on. Okay, and all together is 20. How I get 20 possible arrangement? I can list down like this, or I can use this counting principle, or I can use factorial. Okay, but now you see, when I'm using factorial, okay, 5 factorial means 5 times 4 times 2, but it will come out with 120, which is not correct here. Something is missing, or something have to add up, okay? Meaning to say I do not need the 3 at the back here. Means to say if I use 5 factorial, okay, the word factorial means I will arrange everything. I mean 5 letter, I will arrange all the 5 letter. How many ways? But if you see, if there is only 2 space for me to arrange, okay, from the 5 letter, okay, means I have to cancel some of the possible outcome, okay? So means now the counting principle and the factorial is not equivalent already, okay? Before this is equivalent because we arrange all. You see A, B, C, D, we arrange all, okay? We have 3 letter, we arrange 3 space. But now we have 5 letter, we only have 2 space for it to be arranged. So the counting principle is still can apply, but we stop at 4, I mean 2 space. But factorial principle, okay, the notation, okay, we cannot apply straight. We have to adjust a bit. Okay, how to adjust? Okay, yes, we will do like this. Okay, we will have this formula. Okay, later I will show you how this formula is getting. Okay, so meaning to say instead of 5 spaces, okay, you have 5 letter, you have only 2 spaces, you have to do like this lah, 5 P2. Okay, by using this formula, so let's say just now we understand it. Okay, you have to remove the 3 2 1 here. 3 2 1 is actually 3 factorial, right? That means this number 5 factorial have to divide with 3 factorial. So how to get 3 factorial? 5 minus 2, you see? So that you can get 3 factorial, so you cancel, you get 20, see? Alright, so that means we have to adjust to this. Okay, we have to adjust to this in order to get the arrangement for 2 space. Okay, out of 5 letter, if I only need 2, I have to adjust the factorial notation. Okay, or counting if using counting principle, no problem. Okay, you can just do it. Okay, I mean just continue, it doesn't have any changes. Okay, so let us see the formula now. Okay, now this is the example that we use for 3, right? So we are actually using the same formula. Okay, and factorial over n minus r factorial. You see, just that I have 3 letter and then I have 3 space, so 3 3. So I just put in 3, then 0 factorial is actually equals to 1, so you still get your 6. Okay, for this example that we have previously. Okay, we have 3 to fill in 3 space. Okay, now we see one practice here. Okay, a combination of log to open a right choice of 3 numbers. So the space we need is 3 only, but we have a choice from 1 to 30. Inclusive means include 1 and 30, so there are 31 number. Yeah, please. So you have to have logic on that. So you said there is no number is repeated, means when you use the number 1, then you cannot use 1 again. Okay, it's not repeated. So that means how many different log is possible? So you have 30. Okay, 1 to 30. Oh, sorry, inclusive means 30. Okay, sorry. Okay, so 30 numbers. So out of 30 number, you have 3 space. Okay, so you have 30, then you minus, you have this 30 times 29 times 28, you have 24,360 combinations. So how to solve this? Okay, 30 factorial divided by 27 factorial. So you will do, yes. Okay, you see down here. Okay, down here we will have it to cancel off. Okay, we cancel off the 27 factorial with the 30 factorial. I mean you left with the in front 3 number to multiply on it. So another example here, you have 24 members. Okay, 24 members mean 24 person to choose, and there are 5 seats. Okay, the president, vice president, secretary, treasurer, and historian. So only 5 seats there. Okay, how many possible outcomes that we can have? So 1 2 3 4 5. So 5 seats. Okay, 5 space for the election. Okay, so after that you will use the, of course, okay, this formula, then you will get 5 million, okay, ways of outcome. Okay, so that is to show how we use. Okay, then you try this. Okay, you can try this. There are 10 people competing for the race with 4 ribbons. That means there are 10 people, but only 4 Okay, 4 ribbons are given. Okay, the 4 ribbons are blue, red, green, yellow. So you would use, okay, NP4. Okay, so that one you try yourself. So not just now we are saying we are seeing the permutation without repetition. Okay, now if we have repetition, okay, what is meant by repetition? Okay, let's see. See here. Okay, what happens when you have repeat? Okay, determine the number of way the letter in geometry. So geometry you have 2E, right? So we have repeat letter here. So how many letter in the geometry? 3, 4, 5, 6, 7, 8 letter. So suppose if there is no repetition, we will use 8P8. Okay, then we will get this much. But please, there are 2E repeat. So we have to eliminate. Okay, eliminate some. Okay, some of the arrangement or the possible outcome in this 40,000 is identical. They are the same. So how to delete? Okay, we use divide. Okay, we will divide with the number of same one. Okay, so that's how. Okay, we just take the 8 factorial divide by 2 factorial. Okay, divide by with the same. 2 same to 2p2. Got 3 same, 3p3. Okay, so this one is to account for the 2 identical E. Okay, so this one can extend to any object that are repeated. Let us see another example. So then now is banana. Okay, banana you have repeat A and then there is an N repeated. So altogether 6 letter, but there are 2 letter that's being repeated. So okay, you see the second and the fourth and the 6th letter are A, the third and the 5th letter are N. That means there are 2 N, there are 3 A. Okay, so we have to find the combination. Okay, so first thing, if I were to arrange again, banana is 6p6 nah. Okay, but there inside the 6p6 there are 3 repeated A and then 2 N. So what I will have is, yes, I divide, I do slowly. You can just see I just use the formula. Okay, again. Okay, now 6 factorial divide by 3 factorial. Okay, so 3, 2, 1. So then this one I remain first. Okay, this one I remain at the back. Okay, or you can see I use it faster a bit. Okay, use a faster way. So 6 factorial divide by 3 divide by 2. Okay, divide by 3 factorial divided by 2. 2p2 is 2 factorial, 3p3 is 3 factorial, 6p3. This one we have shown before, okay, the previous example. So after that you can see I can cancel off here. These 2 I simplify with the 4 here. So I will have, okay, 60. Okay, so that means you have only 60 type of outcome. Okay, there are 60 way of arrangement. Okay, yes, you can try this for yourself. Okay, so algebra you have 2A repeated. Okay, so it's quite easy lah. Okay, so I want to arrange 7. Okay, 7 letter. Okay, 7p7 and then divide with the 2 that is repeated, the A, 2p2. Okay, so then you will get.
Then before we end here, I have a short videos on the fundamental of counting. Okay, that you can listen to and then try to understand.
Combination we will continue next lesson. So we will stop here first. Thank you.
The formula for NCR is n factorial divided by r factorial times n minus r factorial. What is this? This is the formula for combinations, but it is not the best way to understand it. And what is NPR? It's n factorial over n minus r factorial. And this again is not the best way to understand permutations. In many books and videos, you would be asked to use this formula if we have to select r things out of n. And we would be asked to use this formula if we have to arrange r things out of n. I can assure you that if you understand just these two formulae, you will never really understand permutations and combinations. There's only one thing you should understand well if you wish to master this topic, and that's counting. If you are able to count well, then the topic of permutations and combinations will be a walk in the park. Of course, the counting will not be as simple as counting on your fingers. It's a little more advanced, but don't worry, counting is easy. Let's say we have 3 pens and 2 markers. Every item is distinct. No 2 items are the same. Here's your first question based on counting. In how many ways can we pick any 1 items from these 5? Understand the question well. In how many ways can we pick any 1 item from 3 pens and 2 markers? In how many ways do you think we can do this? Look at it logically. We can either pick the first pen, we can call it P1, or the second pen, or maybe the third pen. Or maybe we pick a marker, the first one or the second one. We kept saying or. This, or this, or this, and so on. You can see that there are 5 ways in which we can pick any 1 item. And how do we get a 5? 3 ways in which a pen can be picked, plus 2 ways in which a marker can be picked. 5 ways in all. This is the first rule of counting. Or. Or always means addition. First pen, or the second pen, or the third. 3 ways in which a pen can be picked. And similarly, 2 ways in which a marker can be picked. Or always means addition. Now let me ask you another one. In how many ways can we pick 1 pen and 1 marker? 1 pen and 1 marker. Tell me what you think. We have to pick a pen and a marker. In how many ways can we pick a pen? We pick either the first or the second or the third. Now, having picked 1 pen, we need to pick a marker. Maybe after picking the first pen, we pick the first marker. Or maybe after picking the first pen, we pick the second marker. So one way is P1M1 and another is P1M2. Or maybe we pick P2 and then M1, or P2 and M2. In all, we can see that there are 6 ways in which we can pick a pen and a marker. Which are the 6 ways? P1M1, P1M2, P2M1, P2M2, P3M1 and P3M2. And how did we get a 6? 3 ways times 2 ways. Multiplication. And is another rule of counting. It always means multiplication. 1 pen and 1 marker, 3 ways multiplied by 2 ways. 1 pen or 1 marker, 3 ways plus 2 ways. If you understand these 2 rules of counting, trust me, you will be able to solve most problems based on permutations and combinations. And this is nothing new. I'm sure you have used this many times in life. Look at this picture. How many circles do you see? I doubt you counted each circle. Instead of counting each circle, you would have noticed that there are 6 columns and 4 rows. Because it's AND, the number of circles will be 6 multiplied by 4, 24 in all. Don't forget the 2 basic rules. AND is multiplication, OR is addition. The topic of permutations and combinations is not liked by many students and maybe you as well. So we have covered as many topics and examples as we can, and I can assure you that if you watch all our videos based on this topic, you will master the concepts. So take some time, go through our sessions, and you will realize how simple this topic is.